Okay, and we are back. This video is somewhat overdue, but now we're going to start talking about... Actually, we're not going to start talking about... We're going back to systems of equations and just doing a little bit more practice, because I realized that this could use a little bit more practice. So let's look at this first one. So we have 3x minus 2y is equal to negative 8, and x plus 5y is equal to 3. Okay, whoops. Okay, so easiest thing that we can do is we can subtract 5y from both sides of this equation. So we get x is equal to 3 minus 5y. And then we sub it into this equation up here. So we have 3 times 3 minus 5y minus 2y is equal to negative 8. I ran out of room, but just bear with me. So then we have 9 minus 15y minus 2y is equal to negative 8. We can combine these two together to get negative 17y. And then when you subtract both sides by 9, you get negative 17. So you get negative 17y is equal to negative 17. So y is equal to 1. And now what we have to do is we have to sub y is equal to 1 back into one of these equations. So let me just clear this out quickly. So we have x plus 5y is equal to 3. So plug in 1. Oh, why am I so popular all of a sudden? Okay, so sub in 1 for y. 1 for y. I can't write today. Okay, and then x, subtract both sides by 5, negative 2. So our ordered pair is negative 2, 1. Okay, now let's move on to the next one. So you guys always remember that you can, when I write down the problem, you can feel free to jump ahead and solve it yourself. So this one will be 2x plus 8y is equal to negative 8, and 3x minus 5y is equal to 22. So if you want, you can pause the video and try solving this by yourself, but we're going to jump into this right now. So as you guys can see, we don't have a single variable in either one of these. But if you look at this top equation right here, we have a common factor of 2 across all of the values that we have in the equation. So we can pull out that 2, and we can make it x plus 4y is equal to negative 4. And that makes things much easier for us, because now we can just solve for x and then plug that in for x down here. So 5y is equal to 22. So as you can see, if we subtract 4y from both sides, you have x is equal to negative 4y minus 4. And so we can plug in that for x. So we have negative 4y minus 4 minus 5y is equal to 22. So then we can distribute negative 12y minus 12 minus 5y is equal to 22. Add 12 to both sides. Add together the common factors. So we have negative 17y is equal to 34. So then we divide by negative 17 from both sides, and y is equal to negative 2. and now we have to go back and plug -2 into one of these equations for y. So let's just put it into this simplified equation that we have up here. So we have x, let me try to separate this off. So we have x minus 8 is equal to -4. So we add 8 to both sides, x is equal to 4. And that's that problem. So our ordered pair is 4 and -2. Okay, now moving on. Now, let's see, what is our next one? Alright, let's try this one. 6x minus 7y is equal to 23, and 8x plus 4y is equal to 44. Now, much like the last question that we did, as you can see, none of these terms, none of the coefficients are 1, so this makes things a little bit more difficult. But as you can see in this lower equation, there's a common factor of 4 between all of the terms. So we can divide by 4 throughout, and we get 2x plus y is equal to 11. Now we can solve for y, and you get y is equal to 11 minus 2x. So now we can sub in that top equation. So we have 6x minus 7 times 11 minus 2x is equal to 23. Okay, so you have 6x minus 77 minus, or plus 14, because you're subtracting all of this, plus 14x is equal to 23. So if we add all this together now, we have 20x, and then if you add 77 to both sides, you get 100 on that side. So divide by 20 on both sides, x is equal to 5. Now we sub back in to, let's just sub back into this equation to keep things simple. So we have 2 times 5, so 10, plus y is equal to 11. Subtract 10 from both sides, y is equal to 1. So our ordered pair for this one would be 5, 1. Okay, and now we will move on to our final example of this video. So this one will be 3x plus 5y is equal to -27, and 4a, oh wait, whoops, I'm sorry, the original one that was written down was using a's and b's instead of x's and y's, but I don't want to confuse you guys. 10y is equal to -46. Okay. Now, as the previous two examples, there is not one value that will make... There's not one value that has a coefficient of 1. So, but if we look for common factors, this bottom equation does have a common factor, which is 2, but it does not create a coefficient of 1 in any place. So we're going to have to use elimination rather than substitution. So if we take out the common factor of 2, we get 2x plus 5y is equal to -23. So we have these two, and so 2x, so we have 2x and 3x. Oh wait, oh whoops, I'm sorry. I nearly took that in a really complicated way that we didn't need to do, so that's good. 23, that should be 5y. If we just multiply this equation here, by negative 1, we can get it so that the y's cancel out. So if we bring this over here, 3x, not 3y, plus 5y is equal to negative 27. So if we just go through this equation and we add a negative sign to all of these, or in this case a positive sign since it was already negative, and then we go through, we have x, the y's cancel out because it's 5y minus 5y, and then we have left negative 27 plus 23, which is negative 4. So then we can take that and we can go back to these equations. So you have 3 times negative 4 plus 5y is equal to negative 27. So negative 12 plus 5y is equal to negative 27. If we add, whoops, that's 27, I'm sorry. I'm really messing up right now. It's been a long day. It's already noon. So if we add 12 to both sides, we get rid of that 12, and then we have 5y is equal to 15. And, negative 15, I'm sorry. And then we divide negative 15 by 5, and so we get y is equal to negative 3. So our ordered pair would be negative 4, negative 3. And so that concludes our extra practice on systems of equations.